Okay, so I'm going to warn you right now, it's after school on Friday, and they're doing a bunch of construction on the new building out back. So you may hear some fun yelling and machinery noises in the background. Everything's okay. All right, so today, Friday, May 10th, we worked on some more with the transformations. Those are the things that we've been working on in the little 2 questions a day at the beginning of class. So we just kind of expanded on the different ways that you can transform a quadratic function. So a couple of vocabulary terms that we need to make sure that we have in common is the parent function. So I mentioned parent functions before. Parent function in this case it's the original function with no changes made. For example, we're going to deal with quadratic functions. So the parent function of a quadratic function is f of x equals x squared, or we could also say y equals x squared when we want to graph it. So our y coordinate equals the square of the x coordinate. So translation, you might have heard this called like a slide, is when we move the original function up or down, left or right. If we moved a graph, say 2 spaces to the left, we'd say that we translated the figure 2 spaces to the left. Now a dilation, which is this one right here, changes the size of the figure but not the shape. So like next year in geometry, you might look at, say, dilating a triangle. So basically what you would do is you would shrink or expand this triangle exactly the way it is. You do that when you zoom in on your pictures, like on your phone, and you either like spread the picture out or contract the picture. The proportions of the picture don't get distorted, it's just the size of the picture that changes. So that's a dilation. And then a reflection creates a mirror image of the figure over a specific line. When it comes to parabolas or the graph of y equals x squared, the line that we're really dealing with is the line that goes through the vertex. So whatever the y value of the vertex is, we would reflect over that line, basically. I realize that's not a mirror image. It's okay. All right, so let's jump into a couple of different translations. So everything that is near, around, grouped with the x squared kind of creates like a portal to opposite land. Okay, so the number inside the parentheses shifts the graph the opposite direction, that number of spaces. So logically, we would look at this one and we would say, oh, well, we're going to shift the graph of x squared, which is what this is. Well, this is plus 2, so we're going to shift it right 2 spaces. But no, this x squared parentheses, this whole little thing right here creates like a force field of oppositeness. And so what happens is everything around it, you do the opposite of what you think you should do. So with plus 2, we think we should move it to the right, but really what we want to do is we want to move it over here to the left. So my vertex has shifted from 0, 0 over here to negative 2, 0. Now I realize my graph's not perfect, but the overall size and shape of the graph hasn't changed. It's just its position on the coordinate plane that's changed. So over here, I have x minus 3 squared. So again, this whole little thing right here creates that portal of oppositeness. And so it looks like we should move it to the left because it's minus 3. But really, we want to shift it to the right 3. So 1, 2, 3. Okay, so that's our shifting left and right.